Hello, I'm Robert, and so the second half of this video talking about how we can deflect asteroids if they're headed for Earth. So I talked in the first one about Apophis, and as that's probably the most likely thing to happen if we have an asteroid, is that it's not going to be hitting Earth straight away when we find it. That's very unlikely. It's far more likely it's actually going to be missing Earth, like us with Apophis, and then going to hit us maybe the next time around, maybe a couple of decades in the future, most likely centuries really. But if it's a small one, then it could be the century. If you look at the most likely possibility, something the size of Apophis, then it's really very unlikely that one of those is going to hit this century. So it probably has lots and lots of close flybys. But if we just happen to find one that is going to hit us this century, it's still very likely to have flybys. This makes it very easy to deflect. So they are really looking at the worst case when they look at this one. So this go down the wrong way. So, so this is their exercise. That's by the way a mission to go and look. In 2029, we might send spacecraft to go and look at Apophis. It's an excellent chance to look really close up, and it goes so close that the tidal effects on its should actually move little boulders around. This is not actually a photograph of Apophis. It's an illustration, but the artist's illustration. But we could have sent a little spacecraft to go and look at it and actually watch the boulders being moved around by Earth's tides. Just like tides move, the moon's tides move our seas up and down, and Earth's tides is coming so close, you get little boulders moving around because of the tides. So that would be kind of interesting for the astronomers to look at, and the general public. So maybe we'll do that. Anyway, this is the simulation, and this is not a likely scenario, but it is kind of worst case. Then they find this asteroid in 2019, and it's quite large, and it's going to hit Earth they find a chance to hit Earth in 2027, 8 years later, and this is when they discover it. And look, oh, this red line. So these would be them estimating where it's going to be in 2027 uncertainty region. The thing is that they don't know its position. When you've only had a few observations of the asteroid, then it's like if you were a golfer and you're a very good golfer and you hit the golf ball off your tee and you watch it go flying through the air towards the green. Then as it goes flying off into the air, you might have a pretty good idea of where it's going to go. But the further it goes, the more precise your idea of where it's going to land up, because you can see more accurately what its position is. The golf ball isn't changing its position as it gets close to the green. You're just getting a better idea of what its actual trajectory is. And as it gets close, and you might find you've got a hole in one, if you're very lucky, you wouldn't be able to tell that at the beginning, but as it gets closer and closer, it's easier and easier to tell. So it's just like that with an asteroid. But at this point, it's like the golfer looking at the thing is, it's a little bit different. That for a golfer, it's just a circular region. They don't know you're anywhere in the green. But for the asteroid, it just so happens that the way the calculations work, that you tend to know the orbit along a line, positions along a line, that you can work it out much more easily one way than you can in another way. So you get all these positions along the line. It's just the way the mass works. So they know the position of it along this line, but they don't know where it is, so they don't know whether it's going to hit or not. And that's very typical, just because they don't know the orbit very well. Just like with someone with the golf ball, they don't know exactly which way it's going, even though the golf ball, as it were, knows, if you know what I mean. The golf ball isn't changing course, the asteroid isn't changing course, but our knowledge of it changes. So then this is it drawn on the map of the world. Now, this is a FEMA exercise. It's no surprise at all that the track crosses the United States. It's always going to, because not because asteroids have a attraction towards the United States, but because this is an exercise and it's a fictional asteroid. And what's more, you absolutely know, because they've got lots of people there who want to simulate what it would be like to evacuate a city in the event of asteroid impact. So purely because it's fictional, it's not the same for a real asteroid. We know that this one is actually eventually going to hit the United States. It has to, or a bit of it has to. So anyway, that's not much of a spoiler alert. Everyone who goes to the event will know that's going to happen. So But anyway, so we don't know. But then, if fictionally, we don't know. So they then send a spacecraft to try and find out where it is. And here we go. There's the spacecraft. In 2000, so now in 2019 they spotted. It's fiction. It's not going to happen. It's not really going to happen. It's just an exercise. In 2021 they sent a spacecraft. So they and this exercise is done by our top asteroid experts, people who really know their stuff about asteroids. So this is accurate stuff. So they can expect to send a spacecraft there by, say, 2021. And then that gives them time. And then they really nail down its orbit position. And then they, and now impact is hypothetically certain. And the United States and Atlantic Ocean are now at risk. And we know it's going to be the United States, but fictionally they don't know. And so they have these fiction bulletin, and then they gradually narrow it down. So I missed out a bit. So they sent it impacted, deflected in 2024, and that's largely successful. So it was a 200-meter diameter asteroid, which is quite a big one, nearly not quite as big as Apophis, but quite big. And so they reckon that in 8 years is enough time. 2027, going to hit in 2029, 8 years later, is enough time to first send a spacecraft to go and rendezvous and look at it, which would be 2021, and then to send another spacecraft, 3 spacecraft actually, to deflect it, in 2024. And in this exercise they sent 3 Falcon Heavies. Falcon Heavy is our lowest cost way of getting a lot of mass into orbit. That the spacecraft that Elon Musk managed so successfully, a flawless first launch, and so the Falcon Heavy sends a lot of material into space for a very low cost. So naturally they use that, and they send 3 of them, and that is enough to deflect it, and that would have been the end of the exercise. So this might well be what would actually happen in practice. They actually successfully deflect it, but then you'd have all the people there who are simulating the rest of it. They just say, "Okay, we were successful. You can all go home." It's obviously not going to do that. So they're largely successful, but a small fragment breaks off, and this is possible if you hit an asteroid too hard for what it's actually made of. So if they'd misjudged what it's made of, and because many of them are made of kind of loose rubble, and if you hit a very hard impact at it, then a bit of it could break off. So that's what they say fictionally happens in this. They haven't got it quite right. So then now they know, and they've now only got 3 years left, and that apparently is not enough time to do it. Remember, the particular times when it's easier to hit the asteroid, and other times when it'd be very, very difficult because it's the other side of the sun or whatever, it's just in an orbit. It's difficult to get to without a huge amount of delta V from Earth. So you choose the times in its orbit when it's easy to hit it. So it seems it's the 2024 seems to have been their last chance to get it to deflect it before 2027. So now it's a certain impact. So now there's nothing it can do to deflect it anymore in this fictional scenario. In real life, maybe there is. And so they, depending on their orbit and so on, and so it's now just a case of tracking it more and more accurately. So now this is now only 10 days before the impact. We're now in 2027, and if this is New York, and that is the Central Park. So if it was to impact on, so we now know it's going to impact, these are different possible red dots, it means it's roughly that area. And this gives the amount, remember I showed you the other video how you get a lot of blast damage, and that's the, out there, I should look that up, what those different zones are. Does it say? I should get a higher resolution version of this image. But basically you want to evacuate. I don't want to say too much in case I get it wrong. but you want to evacuate that area. There's going to be a firestorm. There's going to be broken winters over a large area, and so you've got 10 days to do the evacuation, and definitely buildings would be knocked over, and that would be pretty devastating. The centre of New York. So you would be evacuating like a major hurricane, and you can do that in 2 days. So you can certainly evacuate New York in 10 days. So basically nobody's going to die of this. But there'll probably also be people evacuating all the art galleries and things, and anything important, precious, to be people sort of taking those away as well. At this time, it'll be a very, very busy time, evacuating New York of all the people, all the hospitals, and people being moved. But certainly, nobody's going to die, and an awful lot's going to be saved because you've got 10 days. And then that's the end of the exercise. And so, and then this is a good video. If you want to find out more about these asteroid impacts, then have a watch of that video, and I've got a link to it there. I'll put a link to it in the description to this. And but to put that in context, yes, I'll bring up this. I just got my little image that I do. It's just a kind of meme thing. It's not. I just bring it. I bring it up quite often. If the Egyptians, and they weren't that far away from an industrial revolution, there were just not so many ideas they'd have needed. If they had developed telescopes back then, that's 4,500 years ago, then they would still be waiting for the first thing they need to impact. So this exercise, if they'd been doing FEMA exercises back in the year 4,500, then they would still be doing them every 2 years, but never actually had to deflect anything. So you need to bear this in mind. Though it's quite important to do these exercises, it's not a very likely scenario. And we get lots of small ones, but with the smaller ones, you probably wouldn't need to deflect them, because most of them are going to hit in the ocean, in the middle of the Pacific or the middle of the Atlantic, or into a desert, or the tundra or something like that. And you would warn people. And so it's actually, I think it's far more important myself. I don't think actually, I think our priorities myself should be not so much on deflecting asteroids as detecting them. Of course, it's important to do this because we might need it, but it's so exceedingly unlikely. And it's likely that we just keep on doing these exercises for another 1,000 years, or even another 5,000 or 10,000 years, and we still mightn't need it. Probably by 10,000 years we'd need it. So I do put this in perspective, and I think that actually it would be a much better sell for the public. They're trying to sell NeoCam and ways of trying to find as many of these asteroids as possible, as quickly as possible. That's a little bit intellectual, a little bit difficult to explain why we need to find the asteroids. Somewhat easier thing to explain, I think, that might be quite helpful, is the SODA mission, which I have on one of my, I'll talk about it separately, but it's a mission which would put a little guard satellite between us and the Sun in L1 position, or close to it, which it has a kind of guard cone around the Earth, which is about 2 days distance from the Earth, and it looks around that entire cone in about 8 minutes, I can't remember, every few minutes, and then as an asteroid crosses the cone, it'll get 2 or 3 or 4 observations of it, and then that is enough to give it a preliminary track of the asteroid. And then and there's another asteroid satellite up there, spacecraft, that does another observation of it. This could give us 2 days warning, which is enough time to evacuate a city. And it would also help with detecting lots of asteroids. But I think it might be a somewhat easier sell to the public, and also very useful, because what we can be pretty sure of is that sometime in the next century or two we'll get a small asteroid. And even if it's just hitting in the middle of the Pacific or the Atlantic, it could save the life of a sailor, or some sailors in a yacht or something. And that's worth doing. And you could easily be that for instance, 8 people died in Mexico in the 1940s of an asteroid impact. 3 reindeer herders died in Tunguska in 1908. There have been quite a few. There have been several this century, and past centuries as well. There's the Wang family. It's a whole family of their house was destroyed at the beginning of the 20th century in China by an asteroid. And a lot. Not many people seem to know about this. There are occasional impacts from asteroids. It's nothing like lightning. It's nothing like even hailstones. Very, very big hailstones. If you spend a lot of time out of doors, if you find your car is being damaged by hail, don't go out and rescue it. Just stay indoors, because big hailstones, big enough to damage a car, which is very, very rare. Then the biggest of those can be really quite lethal. So you need to be careful. Ordinary hailstones are fine, but very, very big ones, big enough to kind of cause dents in the car and that sort of size, and that's quite serious. And that's far more of a risk than a meteorite, in terms of the numbers of people that get killed by them. And then lightning is far more of a risk than that, and things like traffic accidents are far, far more risk than any of that. Just to put it all in perspective. But I think that would be a good way to do it, actually. I think we should be looking at early warning as being a priority, and with detecting lots of them as a side effect of that, then that might be a little bit easier way to get the politicians and general public to do the funding for these for space telescopes. The thing is that space telescopes up in space, above the atmosphere, they can look in infrared and they can see very dark asteroids very easily. And so that would speed up things. But don't worry, because we are going to find lots of them with the LSST, and your personal risk is tiny. So now what have I got left to talk about? So I was talking about, I don't know, I'm going to keep this one short as well, just going briefly. I've got this whole page about methods of deflecting asteroids. And there are lots of ways you can do it. So if you listen to that video, then some of those are explained. Like they talk a lot about nuclear weapons. It's exceedingly unlikely that we have something big enough and with such a short time scale that we actually need a nuclear weapons. If you go back to this, then it's if they had a fleet of nuclear weapons to deflect asteroids, they certainly wouldn't have been used either for those 4,500 years. So it's in fact even less likely. They're not likely to be used at all for tens of thousands of years probably, given the amount of warning. In fact, probably never, because we'd have so much warning by then. So although it's worth looking into them, it's exceedingly unlikely we ever need a nuclear weapon to deflect an asteroid, just because we're pretty much bound to have a lot of warning for something as big as that. So yeah, just methods of deflecting asteroids. But hypothetically, it's worth looking at it in the very remote chance we need it, and there are various other ways of doing it. And then there's this infrared laser idea, and then there's the idea of combining that with the Breakthrough Starshots laser array, which is a way of sending very tiny wafer-thin spacecraft to nearby stars and to the other planets in our solar system, a few hours to Pluto. And this is something that might get built, and if it is built, then it would double rather nicely as a comet deflection and asteroid deflection, and it can deflect those pesky long-period comets, although most likely we don't need this until that time, 1.3 million years into the future, and surely by then they'll have built one of these, if we don't build it in this century. But these would be really rather effective at deflecting. That's a 5-kilometer comet, and this is you deflected by most of them. If you have both ones in both hemispheres, or if you have it in orbit, then that's what you get. That an awful lot of them would be deflected by more than 30 Earth. Are these diameters or radii? Earth diameters. 30 Earth diameters or 60 radii, more than that, more like 70 radii. If you were sending a little pulse of infrared laser light for 8 minutes a day, some number of minutes a day, I think it's 8, how many it is. It says just a few minutes, it doesn't say 8, a few minutes a day, 2 years in advance, which is you're likely to see it more than 2 years in advance, then, and if you have 2 of these, then you'd be pretty much guaranteed to deflect by a huge amount if it's a 5-kilometre comet. So we can actually deflect the big ones as well, the big long period comets, and then even bigger ones if you had more timescale, and which you would have with loads and loads of big space telescopes like we'll surely have 1.3 million years from now, which is when we're most likely to need this. And so I think we're living in the very short time period of a few decades of our civilization when there's still a significant risk, especially from the small ones, where they could hit. But it's not a personal risk. It's not a significant personal risk, but for the planet as a whole, then with the billions of people, then it's well worth putting a fair bit into finding these things, especially because of a low probability scenario, but a devastating one of it hitting a city or hitting an urban area, even though most likely it's 10,000 years before that happens. But like the precautionary principle, it just makes sense to take the precautions, to spell a tiny, almost minute fraction of the world's defence budget on defending not against each other, but defending against asteroids, or just the pocket change for a billionaire for to help find the remaining ones. $50 million is the amount of one of the estimates for space telescope, infrared space telescopes, to pretty much find nearly all of even the fairly small ones in a decade. This of course needs more studies, but the early studies so far suggest that. I mean, if anyone here is a billionaire and has $50 million in their pocket, and then you could just finance a small study like this, you finance it and find out a bit more and double check everything, and then you could be the person who finds nearly all the remaining asteroids. But if not, we have these space telescopes on the ground that they're building really big ones, but we have the ground-based telescopes, really big ones, and they're doing it. There's no quick funding gap for because NASA is so science-orientated. It's very difficult for them to approve one of these projects to look for asteroids, and it just doesn't seem to be a body set up that can actually approve this telescope, and so it's fallen into an awkward funding gap. NASA just keeps saying no, because they are required to assess it by its science merits and not by its ability to defend Earth. So it's just a strange funding gap that we have. It would just take one congressman, I think, with a very keen on this to kind of push it and try and convince others, and we could have it. And it would just take some billionaire, or it would take some small country where they've got a keen leader of the country who says, this is quite an important thing for the world, we'll do our bit. So anyway, I keep saying that just in the hope that it maybe would lead to someone doing something about it, because time after time NeoCam gets beaten by other things, and I can't see that being passed unless someone specifically does a ring-fence budget for one or other of these projects. And there's several of them now. But I personally think the SODA, the one finding it two days in advance, might be the easiest public cell and a very useful thing to have, because actually our main risk is not from these is not likely that we need to deflect them really. So spotting them 2 days in advance, enough to be able to just shout out a warning to someone, then that seems like a pretty good way of doing it. And at the same time, with the 2 days in advance, it would also be finding quite a few extra asteroids as they go flying past, and so it would sort of be doing both at once. It's just a thought. Anyway, I think I've said everything. I'll stop now. But if you've got any questions, and do look in the comments, do look in the description. I will add links in the description, and I will. If any of you see anything, if I've said anything in these videos that if I made any mistakes, and sometimes I also notice a mistake when I go back through it and I listen to it again, then I will put it in the description. And if anybody notices anything, do say in a comment anything that I've, even the smallest mistake, anything like that. Do say, and then any corrections I'll put in the description.